Hello and welcome to the ASP.NET Community Stand-Up. I'm John Galloway, and today I'm joined by Scott Hunter and Rich Lander. So welcome, folks.
Good to be back, John. I don't know when the last time I did this. It was probably a year ago, at least.
It's been a bit. It's been too long. Well, I'm excited to see all the stuff you guys are going to show off. As always, we start with community links, so I'll jump right into those to give us time for the fun demo stuff. So the links, I'm sharing the links for this in the comments. They're in the YouTube show notes, and they're also right here. And that messes up us, so just get them out of the comments. Okay, so first of all, we have, this is cool. I noticed the .NET Foundation blog has started doing these open source spotlight posts. And so this one is going into OASP headers. So Khalid digs through the OASP headers, really nice, easy way to, so this is middleware. And here he turns on this use secure headers middleware. And then this adds these HTTP headers. Secure HTTP headers are super complicated to get right. If you do them right, it makes your site more secure. You do them wrong, and all of a sudden, all sorts of things break, features don't work, etc. So it's kind of nice to use middleware to do this. So you can also go in, as he shows here, and do some more advanced configuration. So you can say exactly what you want to use, or you can set timings or stuff. So this reminded me of, I went out and checked, first of all, I went out and checked his, the site here. This has been updated for over 6 years, which is really cool. And he's got a blog post series as well that talks about how he's built and updated them over time. So a lot more information and documentation. And there is the OASP secure headers. They actually have a project for this, and it has a lot of documentation, guidance, to help walk you through exactly what the headers mean, how to implement them, what the trade-offs are. And in this, there's this technical resources thing here where it lists the different resources you have for different platforms. So in .NET, that reminded me, there's this Net Escapades one from Andrew Locke as well that's been out for a while. I noticed the OASP headers wasn't there, and I got a pull request in to get them to add that. So it's got both listed there. And then, this is the one also, there are two kind of popular header libraries, security header libraries. So this is Andrew's one. Also, this has been out for 7 years. And so there's some trade-offs. They both do a similar thing. There's some trade-offs in configurability and what the defaults are. So I'd recommend checking both of them out. And speaking of Andrew Locke, we've been featuring a lot of his posts as he's been digging into .NET 8. So here he's looking at method call interceptors. And so this is an early exciting feature in .NET. So the idea is that you can replace code in an application by using, you turn on this experimental feature. There's an attribute that you set up, and you basically say, replace this method body with this thing. And so, as always, he goes through, explains what they are and how they work. Nice walkthrough. Here's simple application. Here he goes through and turns on that feature, that interceptor preview feature. And then you can go and add this attribute. Currently, you have to add the attribute. It'll be included later. And then he sets it up here to basically say, replace this with this. And then he goes into more detail about why this is useful, especially things like minimal API. We've had shows recently with David and Damien on to kind of talk about some of the architecture decisions made and being made for ASP.NET, and they've talked about how minimal API was designed for this sort of enhancement over things like MVC and API controllers, which are more kind of imperative and pull things in at runtime. And this is able to do this more AOT and advanced stuff like this ahead of time. So Pretty cool. So he goes through and explains how to do it, gives some kind of limitations and trade-offs and things. All right, just a few more things here. This is kind of neat. This XAML for Blazor. Yeah, James shared this with me yesterday. This is fun. So this is allowing XAML syntax in Blazor. And as I was reading this, I thought, wow, this is really, this seems a little familiar. And indeed, it is based on OpenSilver. So OpenSilver was this kind of Silverlight-based implementation in Blazor, and this is kind of taking that further. So pretty cool stuff. All right, just a few more. So we've got David Fowler blogging or tweeting or Xing or whatever it is we do now. So here he's been digging into, in preview 6, the ASP.NET Core identity stuff. So here's his code sample on that, and showing how you can use these identity bearer tokens instead of JOT tokens. So this is an improvement coming out. And if you don't want to read and type the code, you can also get it from the repo that he links to here. So we'll definitely, as these are kind of shaping up, we'll get the team on to go deeper into these. So, and that's all I've got. So I'm ready to turn it over to you folks. So Scott, you pinged me. You've been working with ARM and containers and stuff and doing some crazy experiments. So can you explain what you've been up to?
Yeah, so I've been doing a bunch of, obviously everybody's aware that we did, Microsoft launched this machine last year called Project Volterra. And what that is that's an ARM64 kind of developer style device. We also have an ARM64 Surface laptop as well, I believe. And I'm sure there's more ARM hardware in the wings. And that's partially because of, we've all seen the great performance that Apple's had with their, M series chips, and they also have extremely good battery life. And so I think ARM is something we're going to see a lot more of. Amazon's got a bunch of ARM in their cloud, and we just introduced a couple months ago that we have ARM in our cloud here at Microsoft as well. So I do think this ARM revolution is happening. I've actually decided to spend the pretty much this whole year using an Apple ARM device as my primary desktop. And that is just trying to go find all the edges in our tools and our products to make sure that if somebody's coming from an ARM-based device, whether it's an Apple device or a Surface device, that there's a good experience for them. And where this all actually started is I was working with Mandy Whaley and Brady Gaster on this demo for Build. It's the OpenAI search demo. It's using OpenAI and Blazor and container apps to build an app where you can actually ask natural language questions to. But I found that I couldn't publish that from my Mac and my ARM-based Mac, and that led to a bunch of understandings in this space. And so what I wanted to do today was just actually go through the same experience I went through and show people how you can make containers aware of multiple architectures.
Cool.
And Rich has got a great blog post, which we'll talk about as well today, which it was March of this year that Rich put a blog post out about how to do ASP.NET and .NET in this multi-architecture being both, AMD 64 and ARM 64. So thought we could just kind of jump into some code, and there's no presentation here. There's no slides. It's just us hacking around.
Cool. Right. So it might be worth just saying, setting a couple things on the stage. So what we're showing here, it's .NET in Mac OS, but it's also .NET in Linux. So it can get a little bit confusing. So the reason that this is all interesting is the MacBook, your MacBook Air or whatever, the M1 device, it is the thing that makes everything ARM64. But the thing, because we're using containers, it's actually ARM64 and Linux primarily, as opposed to Mac OS. So we've had ARM64 support in Linux since I think .NET Core 3.0 or 3.1, sometime in that time frame.
One of those. Yeah.
Yeah, and then we've had .NET, then we've had ARM64 support for Mac OS since .NET 6. So now we're kind of moving to really just polishing these experiences, and that's kind of what Scott's going to talk to us about. Yeah, so that's great. We're pretty far along the way.
And what I'm showing today actually matters even if you're on a Windows device. If you want to publish from a Windows device to say a Raspberry Pi, which is an ARM device, you're going to have the same problems because you're building on, an x64 machine and you're publishing to an ARM 32 or 64 device. So really the whole point of what we're showing is how do you make the tools work in all those different crisscrosses? And the crisscrosses are going to get bigger. As I said, there'll be a point in time when we have a lot of ARM hardware in Azure, and you're going to be on your x64 device and want to publish there. And inversely, you might be on an ARM device, whether it's a Surface or a Mac, and want to publish to an x64 device. And that's going to become more and more common, I think, as time goes on.
And so you mentioned.
Go ahead, John.
Sorry, you mentioned development and also production with Azure or the cloud, and then there's also in between. Often you get like build with GitHub Actions too, right? And that's running Docker, some sort of version as well. So,
and that go ahead, Rich.
I was just going to say the other scenario is mixed teams. So Scott, all three of us are working together. Scott's the total ARM head, and John and I we're on x64, and we have to like work together in a way that makes sense.
Yeah.
Okay, so let's kind of start here. So what I'm going to do is I will minimize Teams. Don't need to see Teams. Okay, so let's jump in here, and I'll share my screen. You guys should be visible.
Yep.
Boom. Okay, so I'll make that go away as well and hide the thing.
The infinity of death.
Right.
Infinity of death. Okay, so I'm just here in a folder. There's nothing in the folder, and I'll do your typical .NET new Razor.
Is there a way to zoom in? Is there a way to zoom in on that a tiny bit, Scott? But yeah.
Yeah, blow it way up. Some people watch on phones or who knows what. Raspberry Pi.
Some of us are a bit aged.
Good enough?
Actually, another couple of clicks more would be good.
Yeah.
Good?
I think that's good.
I think part of the problem is I'm on a huge display.
Yeah.
So, but this is just your typical, .NET Razor-based application that I might start as my for my web application. And for fun here, here it is in VS Code. And to give it a second there, I was waiting for the Solution Explorer down here, and I'll zoom this guy in a whole bunch as well. And so this is, as I said, this is a regular application, nothing special. But what I want to do is I want to use Docker, and I want to use containers. And what we're finding is in the cloud, especially, containers are becoming the unit of deployment in the cloud. And in many cases, it's because you have control. You can actually decide to go, I can make a container, I can put, Mongo inside of it if I wanted to, I can put Redis into it, I can do lots of really cool things, and kind of it orchestrates how the machine in the cloud can be built versus the old way where you go in, create a virtual machine, you log in, install all the software by hand. Just being able to do it with a Docker file is a much cooler way of doing it. So let's Dockerize this application. And so I'll bring up the palette here, and I'll say add Docker files to the workspace.
Yeah.
And I'll select that I want, obviously, .NET. Boom. And as Rich said, we're going to use Linux here. And sure, that looks fine to me. 5105. And so what that did is that went and added the Docker file that I don't see. Oh, Da-da-da.
Well, we're not done the wizard.
Yep. So here we go. We've got all this here. I'm using, I'm always on the latest .NET, so I'm doing version 8. And you can see that I basically have a base version of this with a port exposed. We set this magical environment variable, which makes that work through Docker. And we grab the SDK to do the build. And basically we both build and then we publish the application. So this looks great. So let's jump in the terminal here for a second.
Yeah, so just so you know, those 8.0-preview tags, that's something new that we did with .NET 8 based on customer feedback. So they'll switch to being 8.0 with RC1.
Nice.
That's when the good tags. We'll continue publishing 8.0-preview through RC1 and RC2, but not for RTM. So you'll be able to use 8.0 with RC1.
And so for fun, let's just grab this. And what I'm doing is basically saying Docker go build with the tag of test dot, which is the current folder. And so that's going to go and make a container for me. And this is what you normally do. And I can do that from VS Code as well, and I'll do that in a second. But I just want to do it manually so I can highlight a couple of points here. So Rich's blog post has some great things I stole from it here, like this one. And this is a command that basically says go and inspect the test container and fill out the OS and the architecture for me. So let's do that. And this is exactly what I would expect.
Can you zoom that in at all?
Yeah,
is that possible?
Yeah.
Okay, that's tremendously better.
So you can see here when I ran that, this basically says that I built a Linux ARM64 container. Now, there's a problem with that. I can't publish this container to Azure or any machine that's x64. And so this is great. I can run the container great locally, but there's no way to publish it. And so the folks at Docker added a feature to Docker that solves this. And what that is let's do this. I can specify. I can actually go back down here and specify. What I'm doing is doing the build again, but there's now this flag I just passed, which is -- platform Linux AMD 64. And
I think you might be missing a period. Do you have a period at the end?
I am missing a period, which I will fix.
Yeah.
In the current folder. And so what I'm doing here now is I'm saying go build the container again, but I know I want to publish to AMD 64. So let's go do that. And what we're going to find is we're now broken. And so the reason we're broken is when we passed that flag into Docker, it said go build a AMD 64 container. The way our Docker file is currently built, the problem with that is it's going to actually try to even build the app on AMD 64. So it's going to make an actual AMD 64 container that it uses to build my application. Remember, I'm on an ARM machine. And so while Docker does have the capability of doing emulation, the emulation is not very good, and many things fail. And so literally you should not use the emulation at all. And so you can see this will hang forever. It is broken. It's not going to work. So let's stop that build. And to fix my Docker file is actually really simple. All I've got to do is do that same -- platform thing and stick it in my Docker file. So what I want to do is I want to build. This is my build container. I want to build on my current platform. And so what I'm specifying here is this means what Docker is actually going to do is it's going to create a ARM64 container, which will build my application, and then we will make a AMD64 container as the result. And so all this does is just say, hey, Docker, go use the same platform as the machine I'm on to make this container.
Right. So I should probably a tiny bit more context here. So yeah, perfect. So this tag here, the 8.0 preview tag, it's what's called either a manifest or multi-platform tag. So this isn't a real image. It's actually what you could call like a meta image. It's literally basically a text file that lists the 8.0 preview tag for Linux ARM64, the 8.0 preview tag for Linux x64, and then the client basically has a header to say, or it just reads the file, says which one is the correct match for this client, and then it pulls it down. And so what Scott's doing here on line 8 is he's basically saying, here's the client request that I want you to make. I want you to make the one that matches the build platform, so clearly ARM64, and then yank that image from this thing.
Okay. So it helps it find the correct image.
The big thing, John, is build platform is go grab the image that matches the hardware we're running on. Notice that I did not pass that down in the other ones.
Mm-hmm. Okay.
So this is going to build whatever I specify, but it's going to use ARM64 to build it. That's one of the cool things about .NET is, .NET, the actual code is platform agnostic. So even though I make an ARM64 container, the .NET code it generates will run on AMD64 or ARM64. So I can then take the output of this and shove it into an AMD64 container, and it will just work. Part of the cool aspects of the platform. So let's do this again. And once again, if we can go all the way back. If I go back and say, just do a regular build, nothing's going to change. If I go and say, look at that and tell me what we have, I'm still going to have a Linux ARM64 container. But once again, if I go back here and I specify again, now I'm saying I want Linux AMD64. And I run this, wow, boom, done. Now, if I go look at that, AMD64 container.
Okay.
And right, so and just to further clarify this, so on line 8, Scott has basically overridden, saying, damn it, I want ARM64. But then if you go down to the further down, to the top, based on the way this is written. This line 1, it doesn't have an overriding. So when Scott specifies -- platform on the command line, that is absolutely affecting line 1. Right. So basically imagine there's a -- platform on line 1 that's coming from the command line. Those two things are directly linked.
Okay.
See, before, John, the -- platform affected this one and it affected this one.
Yeah.
Yes.
And so what I did is I said, don't change this one. I want this one to honor whatever I want to build. But the container that I use to actually build the application needs to be based on the same machine I'm actually running on. And so that's what happens. And that's why it locked up before, because when this was trying to build it on a AMD64 container, boom, doesn't work.
Got it. Okay.
It's kind of a mind thing. It took me a while.
Yeah, so the base image and the build image are different, right? The build platform, the build architecture.
We want the base image to be mapped to whatever I specify with my -- platform switch, but I always want the build image to be based on what I'm on. This would work great on a Windows machine running at x64 as well. It'll just hook up, because build platform in that case would be x64. And of course, it's going to build to whatever I asked for, which was x64.
So I think I missed before that build platform. Is that an environment variable that's set by Docker, or is that
yes?
It is.
Yeah, so I've been sending you some links on Teams, John.
Okay.
The last one I sent you fully explains this.
Okay.
So there's a whole set of environment variables that Docker sets that you can use.
If I wanted to, John, I could do this.
Yeah.
This is very explicit. There's also an environment variable, which is the environment variable for what I'm trying to shoot for, target for. And so in this case, I'm super explicit. Okay, grab this one with whatever my target platform is, which is down here. This is my target platform. And then build this one on the build platform, which is the device that I'm on today. Build platform will always match whatever the architecture is of the device you're running on.
Okay.
But you don't have to specify this because by default
it's the same thing. Yeah.
Does it make sense, John? I just want to make sure you're.
It does. Yeah, it's a lot there, though. Yeah, that makes sense now. Okay.
It's a lot there, and you can see how you could easily. This means most Docker files that we have today are not compatible. They're great for building a container for your local machine, but they will not work if you want to target publish to any other platform other than your local machine. And so in the future, I think you're going to see us, we'll modify VS Code. So when it makes this Docker file for you, it'll do this format that I just showed here, versus the format that we had before. So
there's you basically always want that -- platform equals build platform in there. Is that
yes, you do
for the SDK?
Yes, for the SDK.
Yeah. Okay. So another thing is there's a feature in Docker. So Docker build has gone through a few transitions. So there's basically old Docker build, and then there's one called build kit. So these features are from build kit, these environment variables and this slightly different syntax. My understanding is that, and I could be totally wrong, but the Docker desktop for Windows is still on the old Docker build and actually doesn't support this currently. Whereas the Mac OS and Linux one do have build kit. So you need a build kit compatible Docker build.
Okay. We got a few questions that came in. I just wanted to take them as we go a little bit.
Totally.
Would this work with native AOT?
That's a great question for Rich.
Yeah, so I am actually working on that right now. I've been working on that for about the last week. I will share another link with you, John, to show you where my work is for that. The native AOT one works it's very well. The short version is we're trying to make it exactly the same. There's a bit more complexity in native AOT land because it works with it uses Clang, so we have to play nicely with Clang cross targeting.
What is Clang, Rich?
Oh yeah, sorry. Clang is one of the industry C plus compilers. So Clang stands for C Lang, in the same way that Golang. Yeah, we use Clang. The other big one in Linux land is GCC. We don't use that. We use Clang. Clang is in the LLVM universe.
Okay.
What is LLVM?
LLVM is basically a framework for building compiler-oriented and diagnostic-oriented tools. There isn't really a good analog to exactly what it is elsewhere.
Okay. So Rich, just the thing you sent me, I should share that in the comments?
Yeah, you can share all the links that I've been sharing with you.
You can also, in StreamYard, just use the chat over on the right. That's
okay. Okay, yeah, I'm a noob apparently at all this.
Okay.
By the way,
awesome question. Back to something Rich said. The -- platform stuff and the build platform does work in the latest version of Docker for desktop for Windows as well.
It does.
I've used these Docker files on those devices too.
Oh, cool.
Okay, that's good to know.
Okay, two other questions we had. One, I have no idea what this even means. Will RISC-V architecture? What is that?
Yeah, so that's probably a question for me too. Yeah, so we do not have a RISC-V implementation currently. That's so yeah, not a thing. But there is actually a bunch of RISC-V related work going on in .NET Runtime. So and I'm going to share a link in just half a sec.
Okay.
So yeah, RISC-V is definitely moving. Yeah, it's a community project. So Microsoft is helping from the perspective of reviewing PRs, but we actually don't have any RISC hardware that we're testing all of this on. So we'll see where that all ends up.
Okay.
Great question.
And RISC-V is just the next version of RISC. Is that?
I wouldn't quite say it that way.
Okay.
You know, you've got this RISC versus CISC thing.
Okay.
RISC-V is basically an open source chip spec that various folks are implementing. So yeah.
Okay.
I don't think there's a RISC-V that is in relation to that.
Okay. All right. One more question here. This is about, I love ARM. Biggest limitation .NET ecosystem is I can't build ARM container images in Azure DevOps without a local agent.
Well, that Scott just is giving you the answer for that.
Oh, okay.
Yes, yeah. This will work. You will not need an agent to do this. If you have the right Docker files and you pass the right parameters to Docker build, you will not. You can build anything for anything in any space.
Got it. Okay.
And that's what we're showing here is the magic to make this work anywhere you want. You don't have to have a ARM machine to build an ARM container. In my case, I'm using an ARM machine to build an x64 container. Inversely, you could do the other way around. An x64 machine
100%.
building an ARM container with exactly this stuff, and the blog post that Rich is going to point you to will show some of that. Now let's take this to the next level. So I'm happy with the Docker file now. I don't need this anymore. I don't want anything in there I care about. I don't care about. I can close that. And nope, don't need that. I want to run this. And so, one of the cool things about VS Code is I do have the ability to run even, if I want to test this in a container locally, I can. So let's first off, I'm going to go back to the command palette, and I'm going to say Docker build this for me. And you can see it's going to go run down here in the terminal. Boom, boom, boom. And we can close that terminal out. And we can go look and see what that actually built. And actually, I think Rich is going to, let me just do the right thing here. That might not build, that's going to build a dev image, I think. Sorry, I have too much stuff here. I just want to make sure this looks real. Am I forked over?
Well, I mean, the other, well, it might take too long, but we could just delete, well, yeah, we could delete all your images and then rebuild.
Test. So I think this did what I wanted, Rich. I see test.
Okay. You should just be able to type Docker images test, and then only those ones should show up. Yeah, like that.
Yeah, so there's just that. And we can go back and do that inspection again and see what that actually built. And that built
AMD 64.
I'm confused. Yeah. I should not have done that, Rich.
Well,
yeah. Oh, yeah.
This is still the old one. How about you delete that image? Yeah, Docker RMI, and then test. Yeah. So then let's just, now we're clean. Let's just go through the process again. Because right, you started from scratch, right?
I did. This is new from
We were doing this last night.
we were doing this last night. There it goes.
Okay,
So
yeah.
So that's
ignore the man behind the curtain.
There's the ARM container. And why is that important to me? That's important to me because when I want to run the debugger, I can pull down here and do a Docker or .NET launch. And so what this means is now when I run the debugger, it's going to run the debugger in the container. And I want that to be ARM64 because I want to develop and test this container on my local machine, which is kind of important. So if we do this, it's going to go build the ARM container, and it's going to jump over here, and here we are. So I'm now running that container locally. That's great. Let's go back into VS Code. And I now want to publish this, John. So you saw with this Docker file, I can now build and run my container locally and test it however I want to test it. But I want to publish this to Azure. And so in that case, you might be asking yourself before, if you remember, we were actually passing the platform switch.
Yeah.
Well, right. So before we kill the debugger, can we just for kicks show it stopping at a breakpoint, just so people know that actually works?
Sure.
Yeah. So obviously in a .cs file.
Let's go.
We're just like one step away from showing that, so we might as well show it.
Let's go into the main page.
Yeah, exactly.
And
it doesn't really matter where it is, or you could do it in the Razor file too. It's up to you.
The on-get should fire.
Yeah.
Yeah. So you'll have to obviously refresh the yeah.
Bingo.
Yeah.
So I went to the web app. The debugger works. So we're showing that I can both run in a container locally if I want to, and the debugger fully works, and I'm good to go.
Yeah, so debugging does work in containers. That's that's the big message to take away.
The first time you ever run this, you'll see it download the debugger tools when the first time you ever switch it and try to run one of these. But if I want to publish this to Azure, I need to make sure that I publish, I need to pass this -- platform switch.
Exactly.
And so how would I do that? So when I added the Docker file, other things happened too. In my VS Code folder under tasks, a bunch of tasks were created for me. This is the build. So I can do a build. Let's go down here to the Docker stuff. Here's the Docker build. And so which does build. And there's also a build release for doing a release build. And notice on the release build, this is actually in my consideration is a bug in this. Notice it passed for, here's the platform tag, the same platform tag you see right here with Linux and ARM64. Well, obviously I don't want ARM64 and this is the wrong default. So we'll have Shane and company get this fixed. I want that to be AMD64. So what this means, John, if I now build a release container, that release container is going to be an AMD64. So the idea here is locally, when I just do a regular debug build, I'm getting an ARM container that I can both run locally, my breakpoints in, but when I publish this up to the cloud, I want to publish the AMD64 version.
Okay. Yeah.
So that makes sense?
Let's try it.
So let's try it. So let's go.
Right. So we should also add that this platform switch in the JSON file is relatively new. I think it was just added this year.
It was added just recently. This is added when I was complaining to the team about how would I actually do this.
Yeah. They had to do it with the wrath of Scott.
So I forget how we made it build the release build last night. Rich, do you remember?
No. Yeah, it was the command palette that always builds release.
You're right. Right. So if I go back and do a build.
Yeah, that should totally work.
That should make my release build now.
Right. So now we should do your magic test to see what we built.
Yep.
Magic test.
Very magic.
There's my AMD 64. See that? That's what we want. And then what I can do is I can come to my my container here, grab the latest, and notice there's a push. And so what I can do is go to Azure, and I can say push. And what this is doing is logging into Azure. It's now pushing that container to Azure.
To Azure Container Registry.
Yep.
Okay.
And for those that don't know, so there's a private registry offering. So when you get an ACR, it's just for you. It's 100% private by default. You can enable anonymous poll if you so wish. And then when you use container services in Azure, you tell them to pull from Azure Container Registry. Typically, they can pull from Docker Hub too, but I imagine most people use Azure Container Registry.
Okay. So with all that going on, let's jump over here to the browser, and I'll zoom in a bunch. So here we are in my container registry. And what I'm going to do here is I'm going to go and say, I want a container app.
Yeah.
So this is one of our premier solutions in Azure for hosting and running a container. And I'll click create.
Right. It's basically serverless Kubernetes.
Okay.
So I'll give it a name. It's got my demo group. I'll give it a name. The region is fine. The container app environment, that's a cool feature of container apps. Container apps, they run in an environment. And the reason you might choose container apps as a great hosting solution for your .NET applications is the container app environment hosts multiple containers. And what's cool about that is we have this, think of it as a container that you can then put lots of containers inside of. The cool thing about that is those containers are technically in the same network because they're in our environment, which means you don't have to do all the crazy Azure networking things to make it work. But
Okay.
So we got our container app environment.
And then as Rich was alluding to there, like you can do this with Kubernetes, but sometimes Kubernetes feels a bit overkill. It can be kind of complex to do all the wiring up of everything.
So container apps is goofy though. It's got this, it wants to make it where you can do a hello world sample really fast. It's like use quick start image. That means use some container I didn't even build. I don't want that. I'm going to uncheck that.
Yeah.
And then I'm going to go and say, let's go find my container registry. Let's go find the image that we pushed up there. Let's go find the tag, the latest version of that. Boom. So we're good to go there. And next we're going to go to ingress. And ingress means I want people to actually be able to see the thing.
Yeah.
And so I'm going to say accept traffic from anywhere because I want the public to be able to see it.
Nice.
And then I need to give it a port. And so let's go back to that VS Code and go look at our Docker file. Our Docker file's got 5150 in it.
5105.
5105.
5105.
Yeah.
I'm in Van Halen mode.
I know.
So for folks who don't know, 5150 is a Van Halen album. So we're all set up, ready to go. Don't care about tags. So we'll just bingo.
Yeah.
And so now it's going to go and create the container app for me. And so it's going to do a couple of things. It's going to create that container app environment. It's going to create the container app inside of it. And then when it's done, it's going to pull that latest image from the container registry into the application. Once this is set up, if I republish into that container registry with a newer version of the application will update in container apps as well. So let's zoom out here for a second while we wait for this to deploy.
Question while we're looking at or waiting for that. Do container apps work with Windows containers?
They don't today.
Okay.
Today they are primarily a Linux container solution. We have Windows containers in a couple of spaces. Like Azure App Service has a Windows container offering, and AKS, Azure Kubernetes Service, has a Windows container offering. But I would actually, challenge and say most .NET apps are not using Windows capabilities. Most ASP.NET Core apps are not using Windows capabilities. So it really shouldn't matter, unless you're using things like MSMQ or MSDTC or a variety of Windows only capabilities. It really doesn't matter, what you target.
Here's an example here. If they're saying for Crystal Reports for legacy. But
yes, that's a great example of when you would want to use a Windows container if you're using a legacy component like Crystal Reports. So we'll go to the resource here. And I just don't know if this is one of the things that Rich and I were having fun with last night. How long does it take for it to actually pull and get the app? Well, let's try this.
Yeah.
Rich. A great solution here is I'm going to go to log stream.
As it's pulling all these images around, does it handle all the
it should be
layering? Okay, wow.
So it's up. And so if we come over here and click the application URL.
Yeah, it's up. Yeah, it was up. It was up the whole time.
So there you go. I'm on an ARM device, and with a fixed Docker file and the platform support we have in VS Code, it's actually very easy to build and run locally on your natural device, and then publish to a different architecture using the tech we have.
And then for like CI/CD, would this just be kind of transparent with like GitHub Actions build, or?
Yeah, I mean, you would just have to set up your YAML to look very basically identical to Scott's command line.
Like for example, in the customer that asked before, hey, there's no way in Azure DevOps to actually build an ARM container. All you have to do is on your Docker, when inside of your your pipeline, when you run the Docker command, you just pass that -- platform space Linux /AMD ARM64.
Yeah.
And then your pipeline will actually build the ARM thing that you actually want for you automatically. And so this technique works everywhere. And another fun one I can show real quick while I know we have a few seconds or minutes left.
Yeah.
I'll go back to my screen. I went through this whole journey myself when I was goofing around, as I said. Is that shared?
Yeah. It's up now.
So I was actually, this is a really cool, I'll zoom back in again. This is the demo app we showed it build, which is actually, using OpenAI with your own data. So this is like not using OpenAI that goes and does ChatGPT style stuff. This is actually a .NET sample where you can actually put your own files into a folder, and we will scan those files with OpenAI, and you can ask questions to it. This is a PR that I made just a while ago, and you'll notice that this was the old one on the right side here, and I went and added the same thing we just said. Well, actually, no, sorry, I take it back. They had hard coded building. They had hard coded it to the wrong platform. I removed that, and then this is actually the wrong file. I'll show you the right file. This is the file for the dev container.
Okay.
So let me go see if I can find the.
Yeah, DevContainers, another great thing. I've been using those a ton lately.
Yeah, all the remote type features in VS Code are game changers. Just the amount of it's not even productivity, because some of the things you just couldn't do before, period. So I just find them to be complete game changers. Yeah, I've been using tunnels a lot recently, and I find them to be just crazy beneficial.
You know what's funny? The reason you don't see any of that stuff is because I used a version of AZD that solved this.
Oh, okay.
Okay, it's all good. So I actually wanted to get to, John asked this question super quickly that we didn't actually really answer. Can you ask it again, John? This is the one about the layering you said.
Oh yeah. So the Docker images can get kind of big. And I know there's a magic thing you can do with layering where you pull in just the right stuff that you need, and that optimizes things. But honestly, then I don't know the magic that happens. Does this handle that for you?
It's orthogonal to it. So the way we have set up everything, so my team works on or delivers all these base images that people use. We try and make those as small as possible. We try and layer them in the best possible way. And then if you follow our practices, you'll more or less just automatically do the right thing. Because the Scott's app, it created basically just one layer on top of. Actually, you want to bring up that Docker file again, Scott?
Yeah, I will. And I'll show. I want to show something else that's kind of cool too while I'm here. So
so it's basically just that copy at the end creates more or less just one layer. It's a slight lie because like the entry point I think is actually, I don't know, that's not a layer.
This will be too small, but this is kind of cool too. You can see the test container latest, the one we published, that's AMD 64. You can see the warning, my machine saying I don't like that one. Here's the other test one, the dev one. Notice it doesn't say AMD 64. That was showing that our developer container for local dev was ARM64, while the one that we published is that. And let me go back for Rich.
Yeah, so when you push, though, Scott and I were talking about this last night. So when you push your images to ACR, you actually have to push all the layers. It doesn't actually and this is, I think, what it should do, but it doesn't do. It doesn't say like, oh, I know these like .NET layers are in MCR. I'll just like copy those on the cloud side into your registry, and we'll be good. It doesn't do that. That would be, I think, tremendously useful. Yeah, so basically line 23, that's the only layer that you're putting inside the image. All the stuff above is just like, showing your work kind of thing. Like it's just all the stuff leading up to it, but none of the SDK stuff contributes to the final image except via line 23.
Okay.
So
right.
yes, it's perfectly layered.
Okay. So you're doing all the, you tell which image is your base, you're pulling in your SDK and doing your build, and then you're copying that stuff into that. So then that keeps it as kind of tight and small as it can be.
So this is 100% correct.
Okay. Nice.
Yeah, there's a different layering, which is how can I use Docker caching on my local desktop if I'm like constantly rebuilding this thing? And that's why we do this. That's why line 11, 12, 13, and 15 are set up the way they are. So basically what happens is you copy in the project file, you do .NET restore, then you copy in the source code separately. And what that means is if you're only changing .cs files and not the CS proj file, you never need to go back to line 12 because that's cached. Because basically Docker knows that as long as this test.cs proj file is not changed, then line 12 is not invalidated, so we don't need to rerun it. So that's a different type of layering / caching, because all of these lines are basically separate layers on your local machine for dev.
Okay. One other question I had, and I think I know the answer, but let me ask, is there is SDK support for containers now without requiring Docker, but in order to do this sort of thing where I'm specifying the architecture for build and for publish and all that, then I am using.
Yeah, this whole workflow is specific to Docker build and Docker files. The built-in container support also supports cross-compiling in a potential, depending on how you think about it, an even simpler way. Yeah, so that's 100% an option.
Okay.
What we've not done yet, John, is the Docker extension for VS Code is not aware of the .NET platform container build tech. And that's something we'd like to change. I'd like to be able to say, hey, when I, once again, you saw before, if I brought the command palette up and I said Docker build image, Well, that's going to use the Docker file to build that image. Maybe we'll have a mechanism that we can add because we now, I'm running DevKit.
Mm-hmm.
So you see all the DevKit stuff here. We could have .NET build container or something. We could add something here in the DevKit, so you could actually build a container using the .NET tech. And then once you build a container, any of the container images are going to automatically show up here under images. So no matter how I build the container, and then once you have it here, you can push it on up to anything you want.
Okay. Two other questions as we're kind of at time, but these are interesting. So how does this relate to like Docker build and specifying a runtime identifier?
Yeah, so you can do that. In that blog post, it talks about that. So it's in some ways, actually with the Docker file, basically we have this split between building these portable apps and these RID specific apps. Mm-hmm. In the samples that I have, and that I always build RID specific apps, where we use either the RID or -A is the one that I like the best because you only have to specify the architecture. So I do -A and then target arch, which is one of the built-in Docker environment variables. And then you get a RID specific app. It's smaller. Then you're guaranteed that your exe is the right one. Because I think in this example, it actually had don't use app host, because the way this is constructed, the app host is actually going to be built for the wrong architecture. So this is another thing we actually have to work with the people who own these Docker files to fix. So the short answer is yes, it's relevant.
Yeah, if we didn't run out of time, I was going to actually have Rich actually change my Docker file to be architecture to do the -A stuff, the specific stuff, because as the cool thing about .NET is you can build an app on any machine; it'll run anywhere. Mm-hmm. And because of that, we in many cases in some of the NuGet packages carry down ARM stuff and non-ARM stuff, and so we used to call them what fat packages, Rich, or
we called them half fat. Actually, is what we called them. That might not be the most
not the most correct terms to use for these things, but using the -A stuff that Rich is talking about would get you the smallest possible application. And that's also a reason I think in many cases why I would favor a Linux container over a Windows container. If you're not using any of those Windows capabilities like Crystal Reports or whatever, you're going to get a much smaller container with Linux than you're going to get with Windows.
So I just shared another link with John. The -A thing is slightly broken right now. It'll be fixed in RC1. After RC1, it'll just work super beautifully.
Cool. All right. Well, that was a lot of amazing stuff. It's cool that I learned a ton. This was cool to see, and then to understand kind of where we're going, like with some of the fixes you pointed out too, Scott. So,
and of course, I had to wear the red polo shirt too because it's
there you go,
Scott and .NET kind of thing. So,
well, thank you, Scott, and please, anytime you want to be on, anytime you want to show anything off, I'm always looking for guests and speakers and content. So
it'd be fun to come back and do DevContainers, as I said, because DevContainers has the same challenge. If you don't have the images set up correctly, imagine your DevContainer tries to boot up on AMD 64 on my Mac. Well, that doesn't work very good.
No dice.
So we can talk about how to make proper DevContainers with .NET as well.
Awesome. Okay. Well, thanks everyone. And we've got a ton of links in the comments, and I'll add some of those to the description too, show description too. So, all right, I'll wrap up there then. Thanks everybody. Thanks Scott. Thanks Rich.
Thanks folks.